So why did we learn about logarithmic form? Well, the answer is so that we can actually solve exponential equations. So again, let's take a look here. In this particular problem, notice that the x is located in the exponent, so I cannot get the x by itself until it's down on the main level. And the only way we have to get it down on the main level is to use the logarithm definition of this equation instead. So the first step that you want to do if you have an equation in this form is to go ahead and write it in the other form of whatever equation it is that we were looking at. Keep in mind that when we go to rewrite, we always start with log. The base or smaller number in my logarithm is the base of this exponential expression. Then we want to zigzag over here to pick up the number value that it's equal to, and that should get us the log expression that we need, and it will be equal to whatever was in the variable position before. So in this case, by rewriting the expression, notice that I'm able to get the x on the main level. It's by itself, and on this side of the equation I have log base 3 of 15, which is all numbers. In this case, there's no nice easy number that we can get in here. Remember, we're looking for what power of x could you raise 3 to get 15. It's not going to be a nice perfect one. It should be somewhere in between 2, because 3 squared is 9, and 3, which is 27. How can we figure exactly what it is? Well, let's just pull up our calculator. I'm going to go ahead and use my TI-84. I'm going to use just the change of base value formula here. If I want to find log base 3 of 15, what I can do is just use the common log button, find the common log of 15, and then we're going to account for the different base by dividing by the common log of 3. Don't forget those parentheses when you're evaluating. And in this case, I get from that expression 2.46497, so we'll round that up to 2.465. And that's my value that I have for x. Keep in mind, just like with any equation, you can plug this number into the original problem, and you should get something pretty close. In this case, if we do 3 to the 2.465 power, notice I get 15.000436. So it's within rounding differences for what my value of x is going to be, because I had to do some cutoff rounding in the solution part of my problem as well. All right, so that's really just the basics for if the x is in the power, we need to switch it to log form in order to solve it. Now, in this case, notice that the x is in the power, but the base is just 2. I have to have only the base and the exponent alone on one side of the equation before I can switch forms. So in a problem like number 17, what I need to do is I need to get the 2 to the x part by itself first before I can switch to log form. So I need to get rid of the 5, and I need to get rid of the -1, and we follow our same reverse PEMDAS order of operations pieces, and we get rid of the value that's the farthest away or the weakest link in terms of order of operations. So here we have a -1, so we're going to add 1 to each side. That's going to get us 5 times 2 to the x power is equal to 251. The base here is 2 to the x power. The 5 is not being taken to the x power, so make sure you get rid of the 5 before you do anything else. We're going to divide both sides by 5. That's going to leave the 2 to the x power by itself. And on the other side, we have to do 251 divided by 5. Which is 50.2. And now I've gotten the exponential part of my expression by itself. In order to finish solving this problem, I do need to get the x on the main level, and the only way to do that is to switch it to logarithmic form. So rewriting this equation, I have log, my base is 2, zigzag over here to pick up the 50.2 is equal to the exponent, which in this case was x, and it's now all by itself. The x is alone, it's on the main level, and all I need to do now is figure out what log base 2 of 50.2 is. Go ahead and grab your calculator. Again, here I'm going to do my change of base formula, so log of 50.2 using the common log, divided by the log of 2, which was my base, since I wasn't using base 10. And I come up with my solution for x as 5.6496. And that gets the x by itself. All right, one last example here. Again, here I have 5 being taken to the 4 to the x plus 3 power. Then adding 2, notice that this plus 2 here is not in the power, and this whole thing is equal to 212. I'd like to solve for x. X is located in the exponent, and so I'm going to need to use logarithms in order to bring it down out of the exponent and to the main level. However, I can't switch it to logarithmic form yet because there's this plus 2 in the way that's outside of my base and exponent. So I'm going to start by subtracting 2 from each side. And this gets me 5 to the 4x plus 3 power is equal to 210. Now, I want to get the x by itself, but because it's in the power or exponent spot, the only way to bring it down to the main level is to switch it into logarithmic form. So I'm going to say that I have the logarithm. My base is 5 because that's the base of the exponential expression. Zigzag over here, so log base 5 of 210 is equal to everything that's up in the exponent. So that whole exponent was 4x plus 3. So that whole piece is what ends up on the other side of the equation. Now, at this point, notice that on the left-hand side of the equation, I have an expression with a logarithm that does not have any variables in it, so I can evaluate that on my calculator. So over here, I'm going to do the log of 210. Make sure you close that parentheses, and then I'm going to divide by log of 5 because my log expression here had a base 5 in it. So I need to account for that when I'm using the common log button on my calculator. So here I get 3.3223. And it's still equal to 4x plus 3 on the other side. So once you get to a spot where you actually have something you can evaluate like this one, go ahead and go for it. Now, in this case, I'm going to have to go ahead and finish solving this equation for x. The x is on the main level. There's no powers or anything weird on it, so I just want to go ahead and get the x alone following my usual rules for a linear equation. To get rid of a plus 3, I'm going to have to subtract 3 from each side. That's going to get me 0.3223 equals 4x on the other side, and then I can finish getting the x alone by dividing by 4. So I'll need to do 0.3223 divided by 4. And in this case, I'm going to get 0.080, and then we'll round that up to 0.6. And that will get my x value alone. So those are kind of our processes that we can do. If the x is in the power, get it so it's just the base and the exponent and nothing else. Then switch it to log form. At that point, you'll have a log expression with no variables in it, so you can evaluate that on your calculator using what we learned in the last video. And then if the x isn't by itself, then go ahead and finish solving for x now that it's down on the main level.